In this video, we're going to talk about the magnitudes of vectors and what are unit vectors, and we'll look at how we can calculate distance between 2 points. We will look at how to prove that 3 points are collinear, and finally the ratio theorem. Okay, so we start off with the magnitude of a vector. So magnitude, simply in terms of the diagram, it means the length of the arrow. Okay, that's the magnitude. So to find the length, we can make use of Pythagoras theorem. So from this simple diagram over here, to find the length of the red arrow, I can make use of the orange triangle over here. Okay, so to use the Pythagoras theorem, I need to take 4 square plus this unknown length square. Right, so I would write it like this. The length of A, it's question mark square plus 4 square root. Okay, so to find the question mark, okay, what I can do is to make use of the green triangle. Just take note, this green and the orange triangle came from this coordinate, okay, 2, 3, and 4. 2 simply means that you move 2 units to the x, 3 units in the y, and 4 units in the z, right? So I can say that the green triangle will have the length 2 and 3 like this. Okay, so I can find the length of this side now, okay, the question mark, using Pythagoras again. So question mark square will be equals to 2 square plus 3 square, right? So I just need to replace this thing into my formula. I will have the length to be this. Alright, so this hopefully this proves you that, okay, the length of a vector, you can just take the component of the vectors, okay, square each of them and add them together and use square root. Okay, so in general, I can write it this way. If you have a general vector x, y, z, the length formula is this. Okay, so some properties we take note. Okay, if you multiply by a constant to your vector, okay, then the length of the new vector is just k times the length of the original vector. Okay, we can prove mathematically, but let's think of it in the geometrical way. If you remember from the previous video, we said that if you multiply a constant to a vector, you're going to stretch or string the vector without changing the direction, right? So it makes sense that the new length is just k times the length of the old vector. Alright, so that's the first property. Second property is what we call a triangle inequality. So I'll give you a simple diagram like this, okay? So suppose v plus u, according to this diagram, v plus u is like the hypotenuse of this triangle over here. And then, of course, v and u looks like this, according to my diagram. Okay, so what this inequality is saying that the length of the hypotenuse will always be less than or equals to the length of the individual vectors here and here. Okay, so they will only be equal when your triangle, if you can see okay, I have a really skinny triangle, almost like a straight line. Okay, in fact, it's a straight line. Then v plus u is just a straight line. Then of course it will be equals to the individual length add together. Okay, but we don't usually see that case. Usually it's this. Okay. Alright, so let's move on to unit vectors. Okay, unit vectors are vectors with magnitude equals to 1. So what it means is just that the length is 1. Alright, so suppose you have a general vector u, okay, and I just want to make make this vector a unit vector. Okay, so what we understand is that, okay, you can times or divide a vector by a number, right? That's going to stretch or string this vector. So how I can get the unit vector? Okay, it's simply taking that vector divided by its own length, right? Because I know if I do that, the new vector, his length will be 1, right? Because you divide by himself, right? Something like that. Okay, so we denote the unit vector with a hat. Okay, this is called hat. Okay, u hat is a unit vector with the same direction as the vector u. Alright, so that's what I said. Okay, the hat. Okay, to find the distance between 2 points, okay, the easiest way is actually to treat the AB as a vector, vector AB, and we try to find the distance between them. Okay, so let's look at a simple example. Let's suppose you have point A, point B like this. You want to find the distance between point A and B. Okay, so what I can do is to make use of vector. I find the vector AB first. Okay, I can use the position vector formula, OB minus OA, I get this. Alright, and then I can calculate the magnitude of this new vector, AB, and this will represent the distance between point A and B. Okay, that's it. So this is the method to find the distance between 2 points. Okay, so for collinear, when we say that 3 points are collinear, it means that they form a straight line. If I join them together, it's actually a straight line. Okay, so to show that 3 points are they form a straight line, okay, usually there's 2 steps you need to do. First step is to show that in this example, vector AB must be parallel to BC. Okay, of course in general it doesn't really matter which 2 points you use. Okay, what I did here is I take vector AB compared to BC. Okay, but it's actually okay to take example vector AC compared to vector BC. Alright, so any 2 combination of the points is okay. So that's what I have written here. Okay, any 2 combination is okay. And okay, just recall how do we prove that 2 vectors are parallel? Okay, we show that one vector can be written as a constant times the other vector. If you can find this constant, then it means that they are parallel. Okay, so having shown that 2 vectors are parallel, strictly speaking, it's not enough because if you recall, vectors doesn't have to have a fixed position. Okay, so even though I show AB and BC, they are parallel, okay, it doesn't mean that these 3 points are in a straight line. Okay, but I can conclude by saying that, okay, thinking of AB as a line now rather than a vector, a line. Okay, the line is parallel to the line BC and they share a common point B, right? You can see from this example, they are parallel plus they have a common point. Then, of course, these 3 points must be together, right? Imagine if they don't have a common point. So let's say AB parallel to BC. Okay, let me try to draw. Let's suppose BC is somewhere here. Okay, so AB is parallel to BC. Okay, but they don't have any common point. So they don't actually form a straight line. Okay, so that's why the step 2 here is actually quite important. You need to mention that there's a common point. Okay, so that's for collinear. So for the last concept that we will go through, it's the ratio theorem. So the ratio theorem, usually your diagram have to look something like this. It is for us to find the point C. Okay, so what we need is the ratio of the point, the vector AC to CB. Okay, let's in this case let's call it X is to Y. Okay, the length ratio. Then according to the theorem, okay, the point OC, okay, the position vector OC is equals to this formula. Okay, Y over X plus Y times OA, X over X plus Y times OB. Okay, you can go on and memorize this formula. Okay, but I like to understand why it looks like this. Okay, in fact, if you understand how it comes about, this formula comes about, then I would suggest you just use this detour method rather than using the formula. Okay, because just in case you remember the wrong formula. Okay, let's see how I can prove this thing. So same thing, let's suppose I want to find OC. So the idea is to the detour method, right? I need to go to a temporary point first. Okay, so in this case, I'll go from O to A first. And then from A, I will go to C. Okay, that's fine. Alright, so it looks like this. So OA is something I have. Okay, it's something I know. AC is something I don't know. Okay, but I can find AC using the ratio X and Y. Okay, because in a way, I can find AB. I have A, I have B. You see that? I have A, I have B. Okay, so I can say that AC, according to the ratio, it is X over the total. Okay, total it's X plus Y. You can see X over X plus Y times AB. Okay, of the whole length. Then I can rewrite A, B as position vectors like this. Okay, B and A as, again is something that you already know. Okay, so all I need to do now is to substitute this AC formula back here. So we will get something like this. So OC equals to OA plus this thing. And if you go on and simplify this expression, you will get the ratio theorem. Okay, so to me it is not too bad. Okay, this proving is pretty straightforward. You might just need to spend 1 or 2 extra steps to get this final answer over here. Okay, but at least I prefer this because at least you won't have to memorize. Okay, you won't worry whether you memorize the correct formula or not. Okay, so that's for the ratio theorem. So that comes to the end of the video. So make sure now you can describe how to find the magnitude of a vector. What are unit vectors? How to find distance between 2 points? How to prove that 3 points are collinear? And how to describe the ratio theorem. Okay, hopefully you remember the proof. Alright, see you in the next video.